I'm just going to go through this practice test. So we're going to be graphing rational equations. So the things they're asking for: x-intercepts, y-intercepts, horizontal asymptotes, vertical asymptotes, slant asymptotes, and holes. Holes are usually the ones you want to look for first, because if you cancel something, then it's going to end up not being an x-intercept, and it's not going to be a vertical asymptote. So I don't want to list those first. So I'm going to look for holes, which means I need to factor the top and bottom of this. Well, this top, if I try to factor it, 8 can only be 1 and 8, or 2 and 4. No combination of those is going to be -3, so I'm going to use the quadratic formula. So I'm going to have 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 8, over 2 times a, which is just 2. So inside this square root, I have 9 minus 32, which is a negative. And I can't square root negatives, or if I do, I get an imaginary number, which means there are no x-intercepts. Okay, so this thing does not factor. So I'm not going to be able to cancel anything, so there's no holes. There's no x-intercepts. Y-intercepts I get just from plugging 0 in for x. So if this is 0 and this one turns to 0, I've got 8 on the top. This is 0. I've got -2 on the bottom. So that's -4. So that's a point. Horizontal asymptote. This one's not going to have one because the degree of the numerator is bigger than the degree of the denominator. Vertical asymptotes are when the bottom equals 0, so that occurs when x is 2. So I'm going to have horizontal asymptote right here. Slant asymptote, that occurs when the degree of the numerator is exactly 1 larger than the degree of the denominator, which is what we have here. So I'm going to do polynomial long division. So multiply by x, which gives me x squared minus 2x. Change my signs, add them up, get -x plus 8, multiply by -1. Change the signs, add them up. So my remainder would be 6 over x minus 2. To get slant asymptote, I'm going to ignore that, because as we get larger and larger, this is going to go to 0. So my slant asymptote is just this. So the equation for my slant asymptote is y equals x minus 1. And I graph that. Okay, so -1 is my y-intercept. So I guess I shouldn't make it a point, but I'm going to start there, and then I go up 1 over 1 because my slope is 1. So I'm going to get this diagonal line as a slant asymptote. Okay, so now I've got 1 point in this area. So maybe I want 1 more point, so I'm going to plug 1 in. So I'm just going to make a table of values over here. So I put 1 into my function. I'm going to get 1 minus 3, which is -2, plus 8, which is 6. On the bottom, I get -1. So this is -6. So 1 them down. 1, 2, 3, 4, 5, 6. Okay. I know as I go this way, I'm going to keep approaching that vertical asymptote. And as I come this way, I'm going to start approaching the slant asymptote. So that's what's happening left of my vertical asymptote. I need what's right of there. So I'm going to plug in 3, which gives me 9, minus 9, which is 0, plus 8 is 8, over 1, which is 8. And maybe I'll also plug in 5. So 25 minus 15, which is 10, plus 8 is 18, over 3, which is 6. Okay, so it's going to be doing... Okay, I know as I go this way, I'm approaching my slant asymptote. This is going to continue to go up, 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 approach my vertical asymptote. So this is my graph for that one. Next one, the practice test. Okay, same thing. Let's look for holes first. So I'm going to factor the top. The bottom, I'm going to factor by grouping. So out of these two, I can take out a 3x squared, which leaves me with x minus 5. Out of these two, I can take out a negative 12, which leaves me with x minus 5. And out of these two terms, I can take out the x minus 5, which leaves me with 3x squared minus 12. This factors more. I can take a 3 out, which gives me x squared minus 4, which turns into x plus 2 and x minus 2. So that's my bottom, that's my top. So that means one of these will cancel. So my simplified version would be x plus 2 over 3x minus 5, x minus 2. Okay, so I'm just going to erase this. So I cancel the x plus 2 out, and that represents a hole at, and x is negative 2. So to find out where that hole actually is, I'm going to plug negative 2 into my simplified function. That's going to give me 0. So I go over here, put an open circle at that spot. If I'd gotten some other number out, like if it had come out to be 3, I'd have an open circle up here. Let's see. X-intercepts, when the top is 0, that's my hole already, so really I don't have any x-intercepts. Y-intercepts, I'm going to put 0 in for x. So this would be 0, 0, 0, 0, 0. I got 4 over 60, which is 1/15, which is just above right there. Horizontal asymptote, since the degree in my denominator is bigger, my horizontal asymptote is at 0. So that's the x-axis. Vertical asymptotes when my denominator is 0, so that'll be at 5 and 2. Slant asymptote, there isn't one here because my numerator is not exactly one larger than my denominator degree. So there's none. Okay, and now we're on to the part where we just start picking some points to help fill in our graph's behavior. Here, we've got a point here. And so I know that this isn't going to cross 0 again, so it must be following this vertical asymptote up. It's going to come, it's going to hit here. I need to find out what's happening. Is it going to bounce there and come up and stay close this way? Is it going to go below and stay close on the bottom side? So I'm going to plug in negative 3. Okay, I'm going to plug in my simplified version because these two are identical except for at this point. Okay, at this hole, this one's undefined and this one is defined. So all the other points will follow and we'll get the exact same answer, but it's so much easier to plug into this simplified version. So if I plug negative 3 in, on the top I'm going to get negative 1. On the bottom I'm going to get 3 times negative 8 times negative 5. So 8 times 5 is 40 times 3 is 120. So I'm actually, on the bottom side, I'm very close to my asymptote. I guess that's the same thing. So that means I'm going to come out on the bottom and follow my horizontal this way. Test some points in here. Okay, if I get a positive value, I know I'm going to make a U up here because there's no intercepts here, so I know I'm not crossing at all. So it's either going to be a U or an upside down U. So let's plug in 3. Here I get 5. Here I get -2 times 1 is -2 times 3 is -6. So -5/6 is right there. Okay. And if you want another point, we could plug in 4, just to get a little more accuracy. I get 6 on the top. I'd get -1 times 2. It's -2 times 3 is -6, so this is -1. So I get this U. Let's plug in 6. I get 8 on the top. 1 times 4 is 4 times 3 is 12. So that's 2/3. Okay, and that's just going to follow this up and this over. So that's the graph of that one. All right, next page. Another graph here. This one's already been factored for me, which is nice. I can do a little more factoring on the bottom. I can take a 3 out of here, which lets me see that this cancels. So my simplified version would be, well, actually I can take a 3 out of this one too. So my 3's will cancel too. On the bottom I've got 2x minus 5 and x plus 1. This is a simplified version. I've canceled x minus 3, so I have a hole at 3. If I plug 3 in here, I'll get -1. And this is 7, so I have -7 over. This is 6 minus 5, which is 1. 4, -7/4. So I had 3 down, almost 2, so 1 3/4. And that's where my hole is. All right, x-intercepts at 4 and -1/2. Y-intercept, I plug in 0 for all my x's. I'll get -4 and 1, so that's -4. And I'll get -5 times 1, so +4/5. Horizontal asymptote. Since I've got 3 x's on top and 3 on the bottom, I need to know what my leading coefficients would be. So I need to know what would be in front of my x cubed term. Well, x cubed is going to come from multiplying these 3 together. So it's going to be 6x times x times x. So it's going to be 6. On the bottom, it's going to be 2x times 3x times x. So that's also 6. So 6 over 6 is 1. So that's where my horizontal asymptote is. Vertical asymptotes are at 5/2. Okay, setting this equal to 0 and -1. So 5/2 is 2.5. -1. Okay, slant asymptote, I don't have one. So let's start picking some points here. Let's kind of figure out what's happening here. Okay, it looks like I'm up. I'm going to cross. And even though there's horizontal asymptotes here, you can cross a horizontal asymptote. Kind of like we did in the last one. Okay, we did end up crossing over. It's just as you get further down the line, then you're not going to cross back. So I could cross this and come up. That must be what's happening because there's no other intercepts in here, so it's not going to loop back down. So I kind of know what's going to happen, but I want to know how quickly it's happening. So let's put in 2. So if I put 2 in here, I get -2 times 5, which is -10. If I put 2 down here, I get 4 minus 5, which is -1, times 3, which is -3. So I get 10/3, which is 3 1/3. So we're going to do this. Follow that asymptote. Oh, let me undo that. Follow the asymptote, cross the 0, hit the intercept, hit this, follow that up. Over here I've got this hole and this point, so I really don't need any more points, because I know what's going to happen. That. So I need to test over here. Let's put -2 in. -6. This would be -3, so that's 18. This is -9. -1, which is just 9. So I get 2. So I'm going to follow that up and follow this over. I just want to check that one. This is -6. This is -3. -9. -1. Yep, okay. So that's my graph for that one. On to solving rationals. So I like to do where I just get all common denominators and then use my numerators to solve the equation. So my common denominator, if I factor this, I can see that I just need r plus 2 and an r minus 2 on all the bottoms. So to get that on this one, I'm going to multiply by r plus 2 on the top and bottom. And this one needs an r minus 2 on the top and bottom. So we have 12 over my common denominator minus So the only way I can have this fraction minus this fraction equal this fraction when I've got all the same denominators is if the numerators on this side equal the numerator on that side. Okay, because I'm dividing by the same thing every time. So another way to think of it is I could now cancel those denominators out just by multiplying the entire thing by this. That would cancel everything out, all the denominators, and leave just the numerators left. So in order to solve this, I just need to solve the numerator equation. So I've got 12. I'm going to distribute here, so minus 3r minus 6 equals 5r minus 10. This is 6 minus 3r equals 5r minus 10. Add the 3r over. Add the 10 over. So r is 2. Here I need common denominators. So my common denominator is going to be 3w. So I'm going to multiply this by w on the top and bottom. Still need a common denominator here, so I'm going to multiply the top and bottom of this by 3w. Now I can get rid of the denominators and just have my numerator equation. This is a quadratic, so I need everything on one side. And it looks like this one will factor. So I need multiples of 4. They need to be 1 apart. Okay, so now I get 4w minus 3w, which leaves me with positive w. This equals 0, which means either this one equals 0 or this factor equals 0. So here I'll get negative 4/3. Here I'll get 1. And those are my two answers. Oh, something I should mention here. It's important to check for extraneous solutions, so solutions that seem like they should work but don't actually work. And if we look here, if I plug these in, these will both work. But if I actually plug 2 into this one, I get an undefined value here and here. So really, this is an extraneous solution. There would be no solutions. Here, I need a common denominator. I notice that this looks close to this, but it's not quite the same. But if I factor out a negative, it'll look just like this one, because this will become a negative 2 and this will become a positive y. So I'll have y minus 2. I can combine this negative with this one to just turn this into a plus sign. So now my common denominator would be y minus 2 and y plus 6. Or kind of a different, so you could go through the same steps that we went through these, or a different way you could kind of do this one is we could just cancel that denominator out of the left side if I wanted to. So I'm going to multiply both sides by y minus 2. I can cancel both my denominators here, and I'll just have the 4 plus 1. We'll go 25 y minus 2 over y plus 6. This is, of course, just 5. And then I can cross multiply, or I could divide by 5 right away, and that would reduce this. So this turns to 1, and this turns to 5. Now if I cross multiply, I'm going to get y plus 6 equals 5y minus 10. Subtract the y, add the 10. Okay, and then check to make sure that works. Okay, I can plug it in here. I get 4 over 2, which is 2. 1 over 2 is a half. 25 over 10 is 2.5. 2 plus 1/2 equals 2.5, so that works. Finally, writing equations, which is probably the easiest part of the whole chapter. And x-intercepts of these. So these are my factors I get. I need vertical asymptotes. This would be x minus 0, which would just be x. And I like to have my x out up front. And then I have a hole at 1, which means that's been canceled. I need a horizontal asymptote at 0, which means I need more x's on the bottom than I have on the top. Right now I've got 4 of each. So I can pick any one of these factors on the bottom and just square it or cube it or anything that's going to make me have more x's on the bottom. So I'm going to square this one. Now I've got 5 x's on the bottom, 4 on top. So I have a horizontal asymptote at 0. So that's my equation. That wraps up the practice test.